This video is on Dalton's law of pressure. This is the last video for the gases unit. Now Dalton, we've talked about him before when we talked about the atoms back in Unit 2. So pretty much what he has done is he is focusing on just pressure. So if a problem only mentions pressure, you're going to use the formula that we're going to learn here. So the total pressure of a mixture is just the sum of all the partial pressures. So this is extremely easy. The only thing is sometimes students don't read the problem correctly and get things confused. So all you're doing, and this is the formula, PT, T standing for total, is P1 plus P2 plus P3 ... So all it is based on this picture here. In this container we have hydrogen gas, 0.5 moles of hydrogen gas. The pressure is 2.4 atms. In this container we have 1.25 moles of helium at a pressure of 6 atm. When I take these two containers and combine the hydrogen and helium, we end up with 1.75 moles of gas and a pressure of 8.4. So the question is where did the 8.4 come from? How do we know that it equals 8.4? So all you have to do, total pressure, is the pressure of hydrogen plus the pressure of helium. So you just do 2.4 plus 6.0, which gives us 8.4. So literally, you're just finding the sum of the partial pressures of the gases, and that's it. Now there are several ways that I can word these problems. So we're going to do 3 examples. The first one is very straightforward. 2 and 3 have a little bit of a twist to it. So a container holds 3 gases: oxygen, carbon dioxide, and helium. The partial pressures of the 3 gases are 2.00 atms, 3, 4, respectively. The word respectively just means that they're in order of the same order as these guys up here. And the question is asking for the total pressure inside the container. So our unknown is PT. So all you're going to do is PT equals pressure of oxygen gas plus the pressure of carbon dioxide plus the pressure of helium. So that just means you plug those numbers in that are in the problem. So 2 plus 3 plus 4. So 2 plus 3 is 5, 5 plus 4 is 9. Final answer. Now, the other thing I can do with the same formula here, I can give you the total pressure and not give you one of these. So I could say the pressure of carbon dioxide is 3 and the pressure of helium is 4. The total pressure equals 9, and you would have to solve for PO2. So you would simply do 9 equals PO2 plus 3 plus 4, and then solve. So that's why you have to make sure you're answering the question. The most common mistake is to see those numbers and then automatically add them up. That's why you have to read the question and figure out what it's asking for. Now number 2, I bring in percents. So the mixture of gas A and gas B is 125 kPa. This is your PT. It says that is the pressure of the mixture. Gas A has a percent composition of 65%, while gas B makes up 35%. And I want to know the partial pressure of gas A. So when I give you a percent, all you have to do is the percent of A times the PT. That's it. So you just need to do 0.65 times 125. 3 sig figs. And that's your answer. So this formula here is not on the reference table. The other one is. So all you do is you take the percent of the gas times the total pressure and come up with your answer. So number 3 is almost the exact same way. So pause the video, take a couple minutes, and try number 3 on your own. Okay, a container with 2 gases, helium and argon, is 30% helium. Calculate the partial pressure of helium and argon. So it wants to know the partial pressure of helium and argon if the total pressure inside the container is 4 atms. So the PT is the 4 atms. So to find helium, you're going to do the percent of helium times the PT. So the percent of helium is 30, so 0.3 times 4. Which gives you 1.2 atms. Then to find argon, because it's asking for both, you can do this 2 ways. You can do it the exact same way we did helium, or you can do 4 minus 1.2 will give you the same answer. So percent of argon times PT. So if helium is 30%, argon is 70. So 70 times 4, 0.7 times 4 is 2.8 atms. Final answer.